Alright, so here we'll look at substitution method. Reminder, substitution means to substitute one equation into the other equation. So we're going to have to work here. Using substitution to solve systems of equations. So I have two equations here. Here's my system. I'm going to reference this as equation 1, this as equation 2, just to help keep track. Equation 1 we can see is already solved for a variable, y equals. So something we're always looking for is, do I have something easy to substitute in? So y equals 3x. Because y is equal to 3x, I'm going to take that 3x and I'm going to substitute it into the other equation, so equation 2, in for that value it's equal to. So into for y. When I do this, it's going to give me x plus 2. X plus 2 is coming from the second equation. And then in place of y, I'm going to put equation 1, 3x. Now, whenever I substitute an equation into another equation, I'm going to use it, put it in parentheses. That way I can distribute if I need to. This is going to equal negative 21. From here, once I substitute in, I should be left with one variable. So I started with x's and y's. Now I'm down to just x's. So that means I'm on the right track. If I still have an x and a y, after substitute, I've done something wrong. All right, let's simplify. Plus 2 times 3x is 6x equals negative 21. Solve down, 7x equals negative 21. X is equal negative 3. So now I know x is equal to negative 3. That is part of my solution. So my solution is going to be a coordinate. So I'm going to put negative 3 in for x. I still need to find the y value of the solution. To do that, I'm going to look back at my original equations. I have that equation that is equal to y. So I'm going to go right there. Y is equal to 3 times x. That tells me that y is equal to 3 times what we just found x to be, which was negative 3. Y equals negative 9. And that's coming right over here into my solution, negative 9. All right, let's look at example 2. Solve one variable, then substitute. In example 1, I had this equation that was already equal to y. In example 2, I don't have that scenario. So what we discussed was looking for what we call a naked variable. And a naked variable is going to be a variable by itself that has a coefficient of 1. I can see that right here, I have a naked variable. And the variable I'm looking at is x. So, just for reference, I'm going to go equation 1, equation 2. So in equation 1, I have that naked variable x, which is easy to solve for. So if I take x plus 5y equals negative 3, I can subtract the 5y, leaving me with x equals, which is the goal, because now whatever x is equal to, I can substitute equation 2. And that's going to be equal to negative 3 minus 5y. So this is kind of where I'm working with from here. So I'm going to take this negative 3 minus 5y, which is equal to x, and that's going in to my second equation for x. Now if I substitute this in correctly, I should be left only with y's. So let's see what we got here. 3 times x. So x is now not x, it's what x is equal to. So that's going to be the negative 3 minus 5y. So that's the substitution that we're doing. Minus 2y equals 8. I'm going to slide this back. Got to distribute here, so it's going to be negative 9 minus 15y minus 2y equals 8. Combine my terms, so negative 17y minus 9 equals 8. Negative 17y, add the 9 on both sides, gives me 17. divided by negative 17, y equals negative 1. So there's my y value of my solution. So I know y is negative 1. Now I need to find x. Luckily for me, I have this equation now that is equal to x, or this expression equal to x, so I'm going to take this negative 1 and it's going in for y. So x is equal to negative 3 minus 5 times negative 1. Minus negative 5 becomes addition, and equal to 2. So 2 comma negative 1 is our solution for that system. All right, example 3, maybe get a little more challenging here. If I look at example 3, I don't have a naked variable. I have a variable that's really close to being naked, this minus b. The reason I wouldn't consider it naked is because of that minus. It's a negative 1 in front of the b instead of just the 1. So we're going to actually pull the old switcheroo here with this first equation. I have 5a minus b equals 5. What I could do here, I could subtract the 5a over to the other side. Then I have a negative b divided by negative, but I'm going to try to avoid the negative work if I can. So what I'm actually going to do is, and it's nice to do when I have a minus a variable, I'm going to actually add the b. What that'll give me is 5a equals 5 plus b. Now that this b is what we would consider naked, I just have to subtract the 5 to the other side. So I'm kind of moving this b to this side and the 5 back over. So what I end up with here is 5a minus 5 equals b. Now that I have something equal to b, I can substitute that in for b in my other equation. So what that looks like is negative 4a plus 5 times b, and b is now 5a minus 5. Distribute negative 4a plus 25a, 5a minus 5 equals 17. Combine 21a minus 25 equals 17. Add the 25, I get 21a equals 5, 17, 22, 42, and then a equals 2. Substituting that in up here to help find that b, it's 5 times 2 minus 5 equals b. b is equal to 5. I got a's, I got b's, alphabetical, a comma b. So 2 comma 5. And our last one here, already equal to y, so I don't have kind of a pre-step. I can just start substituting right off the bat. So this is going in here for y. 5 times negative x minus 7 plus 3x equals negative 13. Distribute, I get negative 5x minus 35 plus 3x equals negative 13. Combine, I get negative 2x minus 35 equals negative 13. Add my 35, I get negative 2x equals 2. Divide by negative 2, x equals negative. Substituting negative 11 into that original equation, equation 1, so y equals, I get y equals. Now, I'm substituting a negative in for a negative, so it's going to be the opposite of negative 11 minus 7. So that's 11 minus 7, y equals 4. Giving me the solution negative 11, comma 4. And something to note, remember that all of these solutions that we get, we should be able to substitute them back into both equation 1 and equation 2, and it should work mathematically. So that would confirm our answers are correct. All right, hope this helps.